Hello everyone, I'm Divya, your math facilitator. After a long time, we are back with a series of videos. So, firstly, I would like to finish exercise 10.4 for you, and then we shall start few more series like gunshot sessions, most important question series, and all. Okay, so as of now, let us discuss the questions of exercise 10.4. The very first question is here: a metallic sphere of radius 4.2 centimeters is melted and recast into the shape of a cylinder of radius 6 centimeter. You need to find the height of the cylinder. So what is basically happening here? So there is a sphere. Okay, there is a metallic sphere. Okay, the sphere radius is given to you, and this sphere is melted and recasted. Okay, what are you doing? You are melting and recasting. Recasting means you are reshaping, okay, the sphere into the shape of a cylinder. So you actually have a sphere. Now the sphere is converted into the shape of a cylinder. So when I'm melting and reshaping it, so basically whatever might be the volume of the sphere, okay, the entire volume of the sphere is converted into cylinder. So I can simply say the volume of the sphere is equal to the volume of the cylinder. So remember this point. Whenever one particular shape is completely converted to the other, then volume of the original shape will be equal to the volume of the new shape. Okay, because the entire quantity you are converting it to the other shape. Okay, volume remains the same. Please remember this point. Volume always remembers the same before and after. Okay, so now let us see how can we find the height of the cylinder. As I just told you, volume remains the same. So what is volume of the sphere? 4 by 3 pi r cube. And volume of the cylinder is pi r square h. So let me check if I have radius value here to substitute. Yes, radius of the sphere is given as 4.2 centimeter. Okay. And do I have radius of the cylinder also? Yes, radius of the cylinder is also given as 6 centimeters in the question. I need to find height of the cylinder. Very easy, right? So just see here what is given to us. Given. First write what are the dimensions or what is the information given to you in the question. Okay, so radius of sphere is given to us. Radius of sphere is 4.2 centimeter. Let me take it as R1. And radius of cylinder is also given. Let me take it as R2. So R2 is 6 centimeter. And we need to find height of the cylinder, which we don't know. Here, according to the question, volume of the sphere should be equal to volume of cylinder since it is melted and recasted. Okay, always remember one shape converted to the other, then the volume always remains the same before and after. Okay, so here only the entire sphere is converted to entire cylinder, so here volume of sphere equal to volume of cylinder. Volume of sphere formula 4 by 3 pi r cube should be equal to pi r square h is the volume of the cylinder. Here radius of sphere and cylinder are different, so I'm just writing it as r1 and r2. Pi gets cancelled. Okay, so I need h value, so I'll just take r2 square to the other side. So h is equals to 4 by 3 r1 cube into 1 by r2 square. Okay, r2 square is in the numerator, so if I transpose it will come to the denominator. So from here h is 4 by 3. I'm just rewriting the formula what I got finally. Okay, which implies h is 4 by 3 into what is r1 cube? R1 value, radius of the sphere is 4.2. So 4.2 into 4.2 into 4.2. R1 cube, so 4.2 into 4.2 into 4.2. Then into 1 by R2 square. R2 is 6. So R2 square is 1 by 6 into 1 by 6. Okay. So 3 one time, 3, 0, 3 ones are 3 and 3 fours are 12. Okay. So 6 ones are 6 sevens are 42. Here I can write as 0.7 since it is 4.2. Again 6 ones are 6 0.7. So all the denominators got cancelled. So here finally I am left out with 4 into 1.4 into 0.7 into 0.7. Okay, so 4 into 1.4, 4 4s are 16 and 4 plus 1 5. So it will be 5.6 into 0.7 into 0.7. Okay, 0.7 into 0.7. 7 sevens are 49. So 0.7 into 0.7 will be 0.49. 0.49. Okay, since you have two decimal places here. Okay, now we need to multiply 5.6 into 0.49. Okay, so that will give us the height of the cylinder. So I hope there is no confusion in this question now anymore. Okay, just one point we need to remember is whenever one shape is recast into the other, okay, volume always remains the same. Okay, so let us just finish this calculation. So what is 5.6 into 0.49 is giving me around 2.7. Okay, so I'm getting it somewhere around 2.7. So since everything is in centimeter, this is also in centimeter. So height is 2.7 centimeter. Okay, so with this, let us go to the next question now. Have a look at the question. Three metallic spheres of radii 6 centimeter, 8 centimeter, 10 centimeter respectively are melted together to form a single solid sphere. So three spheres you're taking it together. So one sphere, second sphere, third sphere. These three spheres you're melting together. So I'm just writing a plus sign just to understand that we are melting three spheres together. The radius of the first sphere I'm taking it as R1, so it is 6 centimeter. Radius of the second sphere, which I'm taking it as R2, is 8 centimeter. Radius of the third sphere I'm taking it as R3, it is 10 centimeter. All these three spheres together you're melting. What are you doing? You're melting and you're forming one single solid sphere. Okay. So one single big solid sphere I'm forming. Okay. I need to find the radius of this resulting sphere. Okay. So as I told you, again the same point, volume before and after remains the same. So what is the volume before? Before the recasting, I have volume of sphere 1 and this volume is added to the second sphere and it is also added to the third sphere. So all the three spheres volume is added to give you the volume of the bigger sphere. Okay. So the same thing we are going to write here, but let us write the given information first. So given, okay. So three spheres are melted together to give you a bigger one. Okay. And I'm taking the radius of the bigger sphere as capital R, as you can see on the screen. Okay. So what is given to us? Radius of sphere 1, I'm taking it as R1, is 6 centimeter. Similarly, radius of sphere 2, I'm taking it as R2, is 8 centimeter. Radius of sphere 3, I'm taking it as R3, is 10 centimeter. And let us assume radius of the resultant sphere is capital R centimeter. Okay. So, volume of sphere 1 plus volume of sphere 2 plus volume of sphere 3 is equals to volume of the resultant sphere. But what is the volume of sphere? This is important, okay? If you are able to write this term, then substitution of the formula. Volume of sphere is 4 by 3 pi r cube. But since radius are different, I'm taking r1 here. 4 by 3 pi, I'm taking r2 cube plus third sphere volume 4 by 3 pi. Here radius is r3. So r3 cube is equal to the resultant sphere volume 4 by 3 capital R cube. Okay. So now from all these three, 4 by 3 pi, 4 by 3 pi, I can actually take common. See 4 by 3 pi, 4 by 3 pi, 4 by 3 pi. So let us take common. So taking 4 by 3 pi as common. Okay. So you will have R1 cube left over plus R2 cube left over plus R3 cube left over is equals to, on the other side also you have 4 by 3 pi capital R cube. Now 4 by 3 from both the sides gets cancelled. So what do you have finally? R1 cube plus R2 cube plus R3 cube is equals to capital R cube. This is what we have. Let me take a new slide otherwise. So R1 cube plus R2 cube plus R3 cube is equal to capital R cube. This is what I have. Now what is R1, R2, R3? R1 is given as 6 centimeters. So 6 cube plus R2 is given as 8 centimeters. So 8 cube plus R3 is 10 centimeters. So 10 cube is equal to capital R cube. Okay. So we just need to find what is 6 cube. 6 cube is 36 into 6. So 216 plus 8 cube. 8 cube is nothing but 8 eights up 64. So 64 into 8. Okay, you'll have it as 512. Clear? And 10 cube is 10 into 10 into 10. So 10 into 10, 100 and 100 into 10, 1000 is equal to capital R cube. Now what is capital R cube value finally? So 6 plus 2 plus 0, 8. 1 plus 1 plus 0, 2. 2 plus 5, 7. 7 plus 0, 7. And you have 1. 1728 is R1 cube. So what is the value I can get here for 1728? I want a cube value. We know, let us think 1728 cube of it we need. So what is, see here, what is 10 cube? 1000, isn't it? So your 1728 should be, either 12 cube or 13 cube, because 11 cube is very close to 1000. Now 1700 is little more greater than 1000. So let us check with 12 cube. Okay. So I'm just checking with 12 cube. Let us see what is 12 into 12 into 12. Yes. So 12 cube will exactly suit. Okay. So R is cube root of 1728. So R equal to 12 centimeters. Since everything is in centimeter, here also you will take centimeter. If you have any doubt of how to find it furthermore, you can just take prime factorization method. For cubes, what do you do? Three numbers together you will take. Okay, in 8th class you have learned finding cube root, right? So we use that method, or by using trial and error also. Like I said, 1700 is greater than 10,000. So 1000 is nothing but 10 cube. So it should be close to 12 or 13 cube. So like that you can check. Okay, but it cannot be 13 cube, because in 13, what will happen? What is the end digit? If you multiply 13 to 13, you will get 9 here. And if you multiply this with one more 13, you will get a 7 here. Okay. So simple tricks with which we can just try to find out. Okay. So, however, just look into the next question now. A 20-meter deep well of diameter 7 meter is dug. Okay. And the earth got by digging out the well is evenly spread out in the form of a rectangular platform of base 22 into 14 meter. Okay, so this is 22, this is 14. So what are we doing here? We are digging out a well. And what is the shape of the well? Obviously, a cylinder. Okay. So the well is dig and the diameter of the well is given. This diameter is given. So just have a look. The diameter is given as 7 meter and the depth of the well is given. Depth is nothing but I can consider as height of the cylinder. So I'm considering the depth of the well as height of the cylinder. So whatever mud you are getting here, okay, from this, whatever mud I am getting, let us represent here. Whatever mud you are getting here in this, okay, so that mud is transferred into a platform. Okay, it is transferred and is spread out in the form of a platform. And how is the platform? It is a rectangular platform. Okay, the base of the platform is rectangular. So just try to understand here. If the base is rectangular, for example, the mobile is in the shape, is in a rectangular shape, isn't it? So if you see the face, it is a rectangular shape. But if I'm adding height to the mobile, if I'm adding height to it, so this is actually forming a cuboidal shape. You can take any box which you can find around you, okay, which has a rectangular base. So if I'm adding height to the rectangular base, the final shape, the resultant shape is actually a cuboid. Clear? The book in your hand is also a cuboid. Okay, the mobile in your hand is also a cuboid, right? Because it is having some height attached to it. Okay, it is not a 2D shape, it is actually 3D now. Since some height is given here. Okay, so I hope you understood. So rectangle, if some height is given, it becomes a cuboid. Here, whatever mud you are getting by digging the well, when you dig the well, you get mud, right? So that mud is now spread out in the form of a rectangular platform. Okay, in the form of a rectangular platform. Okay, the base of the platform is rectangular shape and platform obviously will have some height. Okay, as you're pouring mud into the rectangular shape, its height increases. Are you able to understand? As I am digging the mud and pouring into the rectangular shape, okay, what happens slowly? The height increases. So as the height increases, now the platform will become a cuboid. Okay, the base of the platform is rectangle, but since height component is added to it, now it becomes a cuboid. I hope this point is very, very, very clear for everyone. Okay, so now when height is added to it, it actually becomes a cuboidal shape. So this height is what we need to find out, height of the platform. Clear? So now let us just write whatever dimensions are given to us. So given diameter of the well is given. Diameter of the well D is 7 meter. So obviously radius would be half of it. So radius of the well, or I can directly write well is in the shape of a cylinder. So let me write radius of the cylinder. R is nothing but 7 by 2, half of the diameter. These many meters. And also depth of the well is given. Depth of the well I can consider it as height of the cylinder, as you can see from the figure. Just look at the figure. Depth of the well I can consider it as the height of the cylinder, which is 20 meters. Okay, and how is a rectangular base? Okay, this is about one shape. Now this shape is converted into a rectangular base. Okay, mud is poured into a rectangular base and it is obviously now it is looking like a cuboid. So let us, in a cuboid you have length, breadth and height. So length into breadth is given as 22 meter into 14 meter. Now how did I write this? See here. Okay, platform of the base, dimensions. Okay, dimensions of the base is given as this. We need to find height. But what is the concept? What is the funda I gave you? Volume before and after is the same. So what is the volume before? Before it is in the shape of a cylinder. Now it is in the shape of a cuboid. So volume of cylinder is equals to volume of the cuboid. Okay, so that point we shall write here. Volume of cylinder is equals to volume of cuboid. Okay, so volume of cylinder formula pi r square h is equal to volume of cuboid is length, breadth into height. So volume of cylinder I can write it as pi is 22 by 7 into radius is 7 by 2. So r square means 7 by 2 into 7 by 2 into height of the cylinder is 20 is equal to length and breadth is 22 into 14 for the cuboid, and height I need to find. Very direct question from this. Can you find height now? Okay, 7 gets cancelled. This, let me take it to the other side. So h is equals to 22 into 1 by 2 into 7 by 2 into 20 into this 22 will become 1 by 22 and 14 will become 1 by 14. Okay, since you're transposing it to the other side. Okay, I hope till here it is clear. So that is equals to 2 ones are 2 11s are 2 ones are 2 10s are. Okay, then 7 ones are 7 twos are 14 and 2 ones are 2 fives are 10 and 11 ones are 11 twos are. So finally you have 5 by 2. 5 by 2 is nothing but 2.5. Everything is in meters. Everything is in meters. So let us also write height in meters. Okay. So whatever dimensions are given here, okay, whatever dimensions are given, the same you use it for the answer. Clear? So height of the platform is 2.5 meter. Okay. I hope there is no doubt in this question. So let's proceed to the next one. We are also going to start one-shot revision sessions, which you're all waiting for. Okay. So I'm also excited and I'm planning, I'm trying to make a perfect plan for you. So once it is done, okay, let's continue the sessions without any break. Okay. So next question, a well of diameter. See, these two are similar questions. Here also a well is dug, okay, and I told you well is in the shape of cylinder. Here also well is dug, but here well, see, dimensions are different. There is a well here as well. Well here as well. So yes, there is a well here. So the diameter of the well is given to you. Just look into this. The diameter of the well is given to you as 14 meter and the depth of the well is given. Okay. So let me take the depth as height of the well. Now, whatever earth you are taking out, the earth taken out, that means the earth means the mud. So the mud whichever is taken out is spread evenly in the form of a circular embankment all around the wall. All around the wall of whom? All around the wall of the well. Okay, so here you, whatever mud you are digging out, that mud you are actually spreading it all around the well. Okay, so well, it is in the form of a cylinder. Okay, the well is in the form of a cylinder. Now, whatever mud you are digging out, that you are spreading it across the cylinder. Is it clear? So the well, when you're digging out it, if you consider it as a hollow cylinder, because since you're digging out mud from it, you can actually consider it as a hollow cylinder. So the mud you're spreading it out, it actually forms like a ring. If you see the base, the 2D, okay, from top, if you see, it will be like, it will look like a ring. Okay, so something like this. If you look at the top, here it is a cylinder. Outside you are spreading mud around the well. You might have seen this construction also around the well. Yes, around the well there will be an embankment. Okay, so it is actually the shape of a ring. Are you able to understand? But here to this ring there is some height also involved. Okay, we are talking about 3D shape. So to this ring, since height is involved, so it actually forms a hollow cylinder. Okay, to circle, if height is given to a circle, then it forms a cylinder. Okay, to a ring, if height is given, it forms a hollow cylinder. Okay, inside you can assume there is nothing inside. Outside there is one more cylinder. Okay, so here I can just consider like this. This is the inner cylinder. Okay, and this one is the outer cylinder. Okay, hollow cylinder I can consider it as two things, inner cylinder and outer cylinder. And if I want the volume of this hollow cylinder, okay, it is nothing but volume of outer cylinder. See, from the outer cylinder, if I subtract the inner cylinder, okay, from this outer cylinder, if I remove this inner cylinder, I'll get the volume of this hollow cylinder, this particular hollow cylinder. Clear? So, volume of the hollow cylinder is pi capital R square h I'm taking for the outer cylinder. I'm taking radius as capital R and height as capital H minus pi So inner cylinder radius I'm taking smaller and height small h. Okay, so this way you can find the volume of the cylinder. Okay, this is a concept for volume of a hollow cylinder. Now coming back to the question, there is a well which is dug and the earth, the mud whichever is taken out is actually spread out in the form of a embankment. Okay, so here around this well, let me consider around the well there is mud spread out like this at some height. Okay, if you see this black color dots which I have drawn, that is actually forming a hollow cylinder. Okay, so this becomes the outer cylinder and the well itself becomes the inner cylinder. And here width of this is given. See, width of the mud which is spread out is given as 7 centimeter. Okay, just consider here if this is the inner circle or the cylinder and this is the outer circle. I'm just taking the top view of the cylinder. Okay, if this is the inner radius, just imagine the top view of the hollow cylinder. Okay, you will find if you look the cylinder from top, you will find a circle shape, isn't it? If it is a hollow cylinder, you will find two circles. Clear? The pipe which you, the pipe example you can take. What else can you take as an example? There are many things. Uh, Insulator bottles. Okay, the thickness of the wall is very much where you can consider inside as the inner cylinder and outside as a outer cylinder. Okay, so that way. So I hope you are able to imagine. For this chapter, imagination is very much important. Okay, yes. Now you see, this is the inner radius and this is the outer radius. So if I want to get the outer radius, see, and this is the width of the uh, width between the two cylinders. Okay, so if I want to get the outer radius from the figure, can you see it is nothing but small r plus w? Okay, so the same we are going to use here. So let us write the given details given. So diameter of cylinder D is given as 14 meter. So which means radius of cylinder R would be equal to 14 divided by 2 is 7 meter. And height of the cylinder, here cylinder in the case we are considering here well dimensions. Okay, height of the cylinder is 15 meter. Okay, now the earth taken out is now in the form of embankment, isn't it? Now this is for the embankment. The dimensions which I'm going to write is for the embankment. So here width of the embankment is given, which means this one is given, this width is given. Okay, width is given as 7 meter. But just now I have explained you a concept. So how do I get the outer radius of the cylinder? Inner radius plus the width. Inner radius is 7 and width is also 7. So outer radius I can get, isn't it? So radius of embankment. Embankment is in the shape of hollow cylinder. Okay. So width of the embankment, capital R. I'm taking it as small r plus w. So smaller is 7 plus w is 7. So 14 meter. Clear? So width of the embankment. The radius of the outer cylinder is given to us 14 meter. Now, now, so the same concept again. Volume of the well should be equal to volume of the embankment. Yes or no? Whatever mud you are taking out, the entire quantity you are just including in the embankment. So both the volumes are equal. Volume of the well is equal to volume of the embankment. Well is in the shape of a cylinder. So volume of cylinder should be equal to volume of hollow cylinder. Okay, whatever mud you are taking out from the well, you are placing it in the form of a hollow cylinder. So volume of the cylinder equal to volume of hollow cylinder. Volume of cylinder is pi r square h. That is equal to volume of the outer cylinder. Now outer cylinder volume, how do I take? Okay, hollow cylinder volume is volume of outer cylinder minus volume of inner cylinder. Okay, so volume of hollow cylinder is a volume of outer cylinder minus volume of inner cylinder. Volume of outer cylinder pi capital R square h. H is same now for everyone. Okay, Height is same. Now here I can take height as of the embankment as capital H if we want. Minus, because here that is what they asked us, height of the embankment. Minus volume of the inner cylinder is pi small r square h. Here height of the embankment is same. Okay. So pi I can take common, and h also I can take common, capital H. So I'll have small r capital R square minus small r square. Okay. Now pi gets cancelled on both sides. So now look at this. So here pi, as I told you, pi gets cancelled on both the sides, pi and pi. So I have small r square h is equals to capital H into, now this, look at this expression. It is like a square minus b square formula. Do you remember a plus b into a minus b? So I can use this. So capital R plus small r into capital R minus small r. Why am I doing this? It will help you in your calculations. Okay, so let's see. So what is small r value? 7. So 7 square. So 7 into 7 into height of the inner cylinder is 15. Okay, is equal to capital H into capital R is 14. So 14 plus 7 into 14 minus 7. Okay, instead of squaring 14 square and 7 square, it is easy to write this way using this identity. Okay, you'll get the same answer. So H into 14 plus 7, 21, and 14 minus 7 is 7. So 7 into 7 into 15. So from here, capital H value I can directly get 21 and 7. These two I'm transposing to the other side. So I'll have 7 into 15. This goes into division. So 7 into 21. 7, 7 cancel. 7 ones are 7 threes are 3 ones are 3 fives are. So which implies height of the embankment is 5. Is everything in meters? Yes. So this is also in meters. So height of the embankment is 5 meters. Okay. So this is how every problem in this exercise we can solve using the same logic, that volume before and after is same. Just that you should visualize everything in your mind when you are doing this chapter. Okay. So remaining 4 questions, let's do it in the next class. And if you're liking the explanation, please do subscribe to the channel and do like the video and share it with all your friends. Okay. Math Facilitator is back, and definitely regular videos you're going to get in this channel, not only maths but also physics. So do subscribe, and yes, since it is again the very first class, I went very slow, but I hope every point was covered. So still, if there are any more doubts, do let me know. And if you need any more topics which you want me to do as a first preference, do let me know in the comment section. And do share this with all your friends. Bye bye. Take care.